liquid gas, those kinds of things, how soft they are, how hard they are, those sorts of physical properties, but also chemical properties, how they react with other substances. Both of those things are true. Okay, that's it for this part. And now we're on to the last page. And so before moving on to the questions on the last page, this is just a quick review of metals, nonmetals, and metalloids. Remember the characteristics about your metals, nonmetals, and metalloids. Malleable and ductile. Malleable means bendable, flexible. Ductile means drawn into a wire. They are shiny. They can conduct electricity. Almost all metals are solid, except for mercury and gallium are liquids. They're really neat. Nonmetals are very brittle if they're in a solid form, like sulfur. The rest of them are very likely to be gases. Almost all of them are gases. Bromine and iodine are not. They're liquids. You can cool them down and make them into liquids, but mostly carbon, nitrogen, phosphorus, oxygen, fluorine, all of these noble gases, they're all going to be gases. And they, of course, don't conduct heat or electricity. Oops, excuse me. Okay, last one we have are the semiconductors in the middle. Those are the ones that have a mix of properties, often used in computing. There's pictures of the different semiconductors, the different metalloids. And then we've got our chemical bonds. So this is where you now need to write in the characteristics about chemical bonds. So we have ionic bonds. They're always going to be between a metal and a nonmetal, whereas covalent bonds will be only between nonmetals, and metallic bonds are only between atoms of the same metal element. So you can't have a bond between aluminum and copper. You can have a mixture of them, which we call an alloy, but you cannot have a chemical bond between two different metal elements. Please note about ionic bonds that in those, the electrons are transferred from the metal to the nonmetal, and then they actually bond because the opposite charges then attract to each other. These are pretty difficult to break, but they're not the most difficult to break. Covalent bonds, in this one, the electrons are actually shared together. So the electrons being shared is what keeps them together. The electrons will actually orbit around both of the atoms that are in a compound, or all of the atoms if there are multiple atoms, more than just two. And it's the strongest type of chemical bond, the most difficult one to break. And then metallic bonds, that's where the electrons are just freely flowing. All of those metal atoms want to get rid of their valence electrons, and so they're just letting them go, and those electrons can freely flow all over the place, which is why they're conductive. They are also very easily broken because the electrons aren't really holding anything together. There's no opposite charge holding things together, so they can be bent, shaped, and cut into pieces. Okay. Now, this is just a little check-in for you to make sure that you can match up the differences. See if you can match up the bond to what its description is. Okay. The last thing that you need to be able to do for this test is write ionic compound names and formulas. You may use the ionic bonding puzzle pieces if you've got yours with you when you take the test. You may not share those puzzle pieces with other people at your table. I will show you when you're doing a question, I'll show you the puzzle pieces to help you think about it. But mainly what you need to know, so for this first example, which I've got the puzzle pieces on there for you, calcium has a charge of +2 and iodide has a charge of -1. So what would be the chemical name and the formula for this compound? Hopefully chemical name is pretty simple. Calcium and iodide together is calcium iodide. Remember, first element gets the capital letter, second element is not a capital letter. and it's always the cation and then the anion, positive before the negative. And then for my formula, to balance this out, I only need one cation, it's a 2+, and then I need 2 of the anions, so that would make up a total of -2 if I have both of these here, and that's how we can balance this out, which is why the formula is CaI2. We only have one Ca, so we don't need to have a subscript here, but we have 2 iodines, so we're going to put the subscript for iodide there. Okay, our next example is aluminum and nitride. So what would be the chemical name and formula for this compound? All right, so if we put these together, we've got one cation that is a +3 and one anion that is a -3. Those are balanced. Those are good to go. So we just need 1 and 1. So there are no subscripts in this. We just put the symbol for aluminum, Al, and the symbol for nitrogen, N, and you're good to go, Aln. Since there's 1 and 1, we don't need any subscripts. Okay, last one, probably most complex one. What would be the chemical name and formula for this compound? Okay. Hopefully, chemical name is still pretty easy to do, aluminum oxide. This is then to figure out the formula. This is where you may need to use some math skills. You can think about the least common multiple of 3 and 2. What would that be? What's the least common thing that they can multiply to get to? That would be 6. 3 times 2 gets you 6. 2 times 3 gets you 6. Multiply against each other. Okay, so that's what we would need to get to. So that means you need 2 aluminum atoms, or 2 aluminum ions, once they've gotten rid of their 3 electrons. And then for all, if this is getting rid of 3 and this is getting rid of 3, that's a total of 6 electrons that need to find an oxygen. Each oxygen can only take 2 of those. So 2 of them can go to this one, and then this guy's going to give 1, and this guy's going to give 1 to this oxygen atom, and then this guy's going to give 2 to this oxygen atom. So we need 2 cations for a total of +6, and 3 anions for a total of -6. +6 and -6 cancel each other out. The total charge of an ionic compound always has to be 0. Okay. So finally, that means the formula is going to be Al2. That 2 comes from, we used 2 atoms of aluminum. And then the O3, there's 3 atoms of oxide. And that is all for your review. Please go back and look at your notes, look at more ed puzzles. Those are helpful. Past worksheets. The built-in atom simulation is helpful. The ionic bonding puzzle pieces are helpful. Come and see me if you want any extra help before the test. Let me know what I can do for you. That is all. Thank you. Good luck on your test.